In Unit 3, we've been learning all about molecules. We learned about ionic molecules and covalent molecules, and in this lesson, we turn to drawing representations of molecules. What's that? Well, that just basically means we're going to draw structures on our paper that tell us about how the atoms are bonded together. These structures are called Lewis structures, and we're going to learn about these for the next 3 lessons. In this video, we're going to specifically focus on giving you the rules you need to learn how to draw Lewis structures. And then we'll work on examples in the future lessons. So first of all, what are Lewis structures? Well, Lewis structures show all valence electrons in a molecule. So here we have water and ethylene. So water and ethylene. And both of them are shown with these sort of skeletal structures with all these lines and letters. What's going on here? Well, these show the valence electrons, like I mentioned, and there's 2 options. Either those electrons are lone pairs, that's electrons that are on a single atom. So, for example, if I look at water around oxygen, those 2 dots there are a lone pair. And they're hanging out just on that oxygen. They're not shared. So that's the difference between a lone pair and our other category, which is a bonding pair, or just bonding electrons. Bonding electrons are shared. So we could summarize lone pairs as unshared, and we could summarize bonding as shared. Some of our electrons are shared and some are not. So where are bonds? Well, bonds are those sticks you see, and this is a bond. Those are 2 electrons. So every line you see is 2 electrons. Here, these are bonding electrons. You see 2 lines, that's what's called a double bond. That means there's actually 4 electrons there. So 2 lines, 4 total electrons. The lone pairs, well, there's no lone pairs on ethylene. Every single valence electron is being shared. There are lone pairs on water. How many lone pairs on water? 2. There's 1 lone pair, and there's 2 lone pairs. So we can count lone pairs, and we always recognize them as the dots that are hanging out around an atom, and they're unshared. And we can also count our bonding electrons. So for example, how many bonding electrons are there around this carbon? Well, there's 1, 2 electrons there, 3, 4, 5, 6 electrons there, because a double bond has 4 electrons, and then 7, 8 if we include that. So around that carbon there are 8 electrons. We'll see that's actually pretty common. Okay, so those are the 2 different options for what our valence electrons are doing. All right, let's take a look at an example. Our whole goal in Lewis structure problems is going to be to start with something like this. We'll have a H, a C, and an N. We'll have a number of different elements and how many there are, and we want to draw what that molecule looks like. First of all, that's crazy that you can just, from looking at the elements involved in a molecule, think about it and tell me what the molecule actually looks like. So eventually you'll be able to go from HCN and you'll know, hey, it actually has to look like that. And what we're going to do is we're going to use this HCN molecule to go through all the rules for our Lewis structures. Okay, rule 1, the total valence electrons have to match. So valence electrons come from my hydrogen, from my carbon, and from my nitrogen. And those are the only electrons I can have distributed in my valence and my Lewis structure, because remember, Lewis structures just show valence electrons. You can count your valence electrons with the periodic table. If you're not familiar with this, check out my other video on valence electrons. And let's do that. So for hydrogen, we have 1. All we do is we count from the left-hand side of the periodic table until we get to that box. And so here we just have 1 box to get to hydrogen. So there's 1 valence electron. For carbon, I have to go through hydrogen, that's 1. Oops, sorry, hydrogen's on the wrong row. Let's start with lithium, huh? So carbon's down here. And so we start with lithium, and we go 1, 2, 3, 4. So carbon has 4 valence electrons. Now nitrogen. Nitrogen is just next to carbon, and so we count from left to right until we get to nitrogen. 1, 2, 3, 4, 5 valence electrons. So that means altogether, those give me 10 valence electrons. Well, let's make sure that HCN is following that rule. Let's count the electrons. Here you see for the first time what's called a triple bond. So we see 3 lines, and each of those lines represents a pair of electrons. So let's count our electrons and make sure they add up to 10. So here is 2 electrons. because there's just one line. Those are shared electrons, and there's 2. Then in our triple bond, we have 1, 2, 3, 4, 5, 6. So that's 6 electrons. And lastly, we have our lone pair, which is 2 electrons. So now when we add those up, we get 2 plus 6 plus 2, or 10 electrons. So that's the whole point of this rule. The number of valence electrons that each of my elements gives matches the number of valence electrons I've drawn in my structure. And that always has to be true. If you add extra electrons, that's going to make your molecule charged, and it's not going to match what they gave you in the original structure. So you can't just add electrons or remove electrons. The number of valence electrons has to match. Okay, that's rule 1. Rule 2, the octet rule. Very important rule. Most atoms want 8 electrons. Hydrogen turns out to want just 2, and so that's an important exception to that rule. And electrons and bonds count towards both atom totals because they're shared, and so we get to count them both directions. So what we want to make sure is that all of our atoms have 8 electrons, unless they're hydrogen, in which case they want 2. So let's double check that. All right, let's start with this carbon. Remember that every single one of my bonds, those electrons count towards both the atoms that they're connected to. So in other words, if I look at this bond right here, those 2 electrons count towards nitrogen and towards carbon when I'm looking for the octet rule. They're shared, and so they both can go towards satisfying that. So let's just count up how many we have around carbon. That's 2 electrons. And then I have 3, 4, 5, 6, 7, 8. So 6 electrons total from my triple bond, 2 electrons total for my single bond. When I add those up, I get 8 electrons. That's the octet rule. It matches. It's happy. Okay, let's try and check out nitrogen. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So again, 8 electrons. Each line counts as 2 electrons, and then each dot you see is 1 electron. So that's 8 electrons. So both nitrogen and carbon in this molecule have an octet rule. And these rules combine to help you know where electrons must go in a molecule when you draw Lewis structures. All right, the last thing to check is hydrogen. And remember, hydrogen's kind of an exception. It doesn't actually want 8 electrons, it just wants 2. And so when I look at hydrogen, I see it has 1 bond connected to it, which contributes 2 electrons. So it follows that rule also. Okay, so the first 2 rules. The total valence electrons on my molecule have to be correct. They have to match what each atom brings to the table. The octet rule tells us that once we've formed all these bonds between our atoms, that each atom typically wants 8 electrons. There are exceptions to that. Hydrogen is one, and in a future video we'll go over other exceptions. Okay, what are other rules? The third and fourth rule I'm going to list together because they're pretty quick. One is that hydrogen always comes on the end. We call that terminal. And that's actually because they can only have 1 bond because they only want 2 electrons, so they're always going to be at the end. Now, one key question you'll have when you're drawing a Lewis structure is what should I put at the center, right? So I see HCN. Well, I could put carbon at the center or nitrogen at the center. The correct structure has carbon at the center. Why is that? Well, the rule here is that elements to the left on the periodic table are in the center. So carbon is going to be in the center. So there's a number of reasons for that, which we won't go into, but just know that as you go to the left on the periodic table, the further they are on the left, that's more likely to make them central. Okay, so those are the rules for Lewis structures. In our next video, we'll actually start to draw some simple Lewis structures using those rules. Thanks for watching this episode of Real Chemistry. If you have any questions, leave them below. Hey.